Thank you for joining us in this nature documentary. We will be talking about the amazing national park, the Olympic National Park. This park is located in Washington and covers nearly 1 million acres. The weather often changes in this national park, and one of the most popular places to visit is the Hurricane Ridge, which traditionally has 30 to 35 feet of snow. There are many biomes in this park, but the main one is the temperate rainforest. There are many biotic and abiotic factors in this environment. Some abiotic factors include mountains, precipitation, and sunlight. Biotic factors include bears, strawberries, and different kinds of fish. The energy pyramid is a way of modeling all of these organisms, and are represented using the trophic levels of this pyramid. The energy originates from the sun, then goes to the producers, which is a group of organisms that create their energy from the sun. The example we will use for this video is wild strawberries. The second trophic level is the primary consumer, which eats the producers for energy. This will be represented by the snowshoe rabbit that lives in the national park. These rabbits are herbivores and eat strawberries and sometimes different types of moss. The next level of this trophic pyramid is the secondary consumers, which will be represented by the fishers, who were reintroduced into the Olympic National Park. They disappeared after overtrapping animals and have recently been reintroduced to the Olympic National Park. The hereditary predator or the apex predator is the cougar. They are rarely deadly and are strict carnivores. This animal keeps the population of all the other animals in check. Even though this graph shows the flow of energy, it does not mean that all the trophic levels get the same amount of energy. The producers have the most amount of energy, and the next level will only get 10% of that energy. This is continued throughout the entire pyramid. The hereditary consumer will get the least amount of energy, and the flow of energy is called the rule of 10. This is why this is a flow of energy and not a cycle. Including producers and consumers, there is another category of organisms, decomposers, and their job is to break down dead or decaying matter, or the waste of other organisms. The main decomposer in this national park is banana slugs, which help break down a lot of dead animals and waste in this national park. Matter also flows through our ecosystem in different ways. For example, different plants in the Olympic National Park, such as Douglas fir trees, huckleberry shrubs, and red alder trees, use photosynthesis by taking in sunlight, water, and carbon dioxide to produce glucose and oxygen. Other organisms, including the Olympic chipmunk, Olympic marmot, and short-tailed weasel, use cellular respiration, which use oxygen and glucose to produce carbon dioxide and water. The carbon cycle is also in this ecosystem, where carbon is cycled constantly. For example, carbon goes into the atmosphere when an organism dies or begins to decay. When an organism performs cellular respiration, some of the carbon dioxide ends up in the ocean or taken by plants and trees. Invasive species hurt our world in many ways, and even the Olympic National Park has a few of them. One of them is the English ivy, which is a plant that has disrupted the ecosystem of many plants. Because not many primary consumers enjoy eating this plant, it has begun to reproduce very quickly. This is bad as it is competitive with native species of plants and takes a lot of their resources, such as sunlight, water, and even space. They can also kill and pull over trees. They were introduced to the Olympic National Park on purpose by early English settlers for ornamental purposes and start to wreak havoc into this park. There are also interactions between organisms that are present in this national park. For example, the relationship between most of the trees and the wood-boring beetles. These wood-boring beetles attack the tree and cause the tree to die. However, this beetle gets shelter and food from this tree. Because one organism benefits and the other gets a negative impact, this relationship is known as parasitism. The relationship between fungi and algae are mutually beneficial, which is why this relationship is known as mutualism. The fungi and algae live together on the bark of most trees and help each other survive. The fungi provides the structure while the algae provides nutrients using photosynthesis. The salmon and phytoplankton from the national park have another relationship. The salmon eats the phytoplankton for nutrients and food. This is called predation, which is another relationship when an organism consumes another organism for nutrients and food. All is well in the Olympic National Park when all of a sudden an invasive species comes and begins to destroy the ecosystem. The native species of this park begin to disappear, and the biotic and abiotic factors begin to suffer because of this organism. Because this invasive species has no predators in its environment, it became reproducing and quickly began to consume all of the secondary consumers. This makes it so that the hereditary consumers begin to die off because of a lack of food. Secondary consumers also begin to die as there are too many invasive species that are consuming the animals. Primary consumers, however, begin to flourish because of the decrease of its natural predators. Because of the amount of primary consumers, the producers then begin to die, and the ecosystem is thrown off balance. Because the invasive species competes for abiotic factors as well, water and shelter become scarce for the other animals. The carbon cycle will also collapse. It would increase in producing carbon as there is an increase of animals breathing carbon. However, it would go to the atmosphere as there's no plants to take the carbon in, and the carbon cycle erupts into chaos as there's no more plants to absorb the carbon dioxide, and all of it goes into the atmosphere. Biodiversity decreases as well as there's only a few primary consumers and the invasive species left. To get the ecosystem back in working order, we need to remove all of the invasive species. We also need to reintroduce the animals that were taken away back into the environment. It would take a long time, but this would work. Thank you again for watching, and I hope you have a great day.